Hello everybody, welcome to this video on capacitated facility location model. So the model that we're going to talk about today is the most complex capacitated facility location model that we will cover in this class. Now this is an extension of the model that we did last week. Here, here's a simple picture that explains the model that we are going to go over today. We have a set of suppliers that we know. We have a set of market or demand locations that we know. We know the capacity available at the suppliers, and we know the demand available at the markets. What we don't know are which plants. So we have a list of potential plants that we can open, and we have a list of potential warehouses that we can open. Right, so we have to simultaneously make decisions about which plants to open and which warehouses to open. And but the data that we have is data for the suppliers and for the markets. Now, this, like I said, is an extension of the previous problem that we did. Here, there are 3 stages to the supply chain. Unlike the previous case, we looked at a case where we had 2 stages. Now, once you understand this, you can obviously see how you can extend this to multiple stages in the supply chain. Now, as far as the way you formulate it, so obviously we are going to formulate this as a linear programming problem, and we're going to solve it. So when formulating it as a linear programming problem, you will notice that the decision variables that we need to consider, there are multiple decision variables that we need to consider. Oops, I'm going to, I think I must have slide there. Like I was saying, there are multiple sets of decision variables that we need to look at. So in the previous case, we had one set of x variables and one set of y, 2 sets of x variables and one set of y variables. Each stage of supply chain has a set of x variables. X variables are essentially variables that tell you how many units are shipped from one stage to another, and y variables tell you whether a particular plant was open or not. In this case, we'll have 2 sets of y variables and 3 sets of x variables. And the simplest way to think about them is, if you look at the picture that we had before, here, you'll notice that there are arrows going out of the suppliers, arrows going out of plants, and arrows going out of warehouses, tell you how the items are going to flow. So every arrow, every potential arrow that you have is a decision variable. So you have one set of decision variables here, one set of x variables here, a second set of x variables here, and a third set of x variables here, which will depend upon how many potential warehouses and market locations there are, plants and warehouses, and supplier and plant locations. We'll see a concrete example in a few seconds, but that's what you have as far as the variable decision variables related to the flow is concerned. Apart from that, we also have 2 sets of decision variables that have to do with whether or not which plants you're opening and which warehouses you're opening. And as you know, these variables are going to be binary variables, 1s and 0s. So instead of just having a single set of 1, 0 variables telling you which plants are open, you're going to have 2 sets of 1, 0 variables telling you which plants and which warehouses are going to stay open. Right? So these are all the variables that we will assume are known. So some of these is technical. So the important things to remember is that we assume that demand at the market locations are known. We know that the potential capacity of each of the plants is known. And we also know the potential capacity of each of the warehouses. So we are assuming that warehouses don't have infinite capacity. Warehouses also have limited capacity, and we know what those limited capacities are at the warehouses. We know the fixed costs of opening and running the plants and the warehouses. And of course, we know the cost of transportation and manufacturing, if that is included in the problem. All the variable costs are also known. So given that, we can see that the decision variables look like this, and of course the objective looks like this. So if you look at this, there are 5 parts to the objective function. These are the fixed costs of opening and running the plants, the fixed costs of opening and running the warehouses. Now this is the variable cost of transporting all units from your supplier to the plant locations. This is the variable cost of transporting materials from the plant locations to the warehouse locations, and the variable cost of transporting items from the warehouse locations to your demand or market locations. So these are all the variable costs. So when we set this up in Excel, you will notice that we'll be writing multiple sum product functions to represent these sum products that we have here. And of course, we have to obviously talk about constraints. Now, in most of these network problems, this network sort of problems, the number of circles or nodes that we have, circles, squares, however you represent them, the number of nodes that you have and the number of arrows that you have sort of give you an idea of how many constraints or how many decision variables there are. So the usual way to think about it, every arrow that you draw in a network represents a decision variable. That's a possible flow. That's a possible X decision variable. And of course, if you are looking at opening or closing plants and warehouses, you have the corresponding Y decision variables. Now let's look at the constraints. So every node that you have, every potential location that you have will have a constraint associated with it. These are the first set of constraints. This is the supply constraint. So this is how many units you can get from each supplier, which is constrained by how many units are available at the supplier. This is the transshipment constraint. So the way when we write this, we're going to write this as equal to. You don't have to write this as greater than or equal to. So this is an equal to constraint, which says that all the items that come from the warehouse locations, from the supplier to your plant locations, have to be transformed into products and sent to the warehouse locations. So this is a transshipment constraint. Now this is the capacity constraint. So this is the transshipment constraint from supplier to plant. This is the capacity constraint at the plant. So saying that the total number of units that are transported, that are sent from the plant to the warehouse, cannot exceed the capacity of the plant. And the capacity of the plant is decided by the Y variable. If the plant is open, the capacity is available. If the plant is not open, the capacity is not available, right? So that's what you have here. And then this is the transshipment constraint for items going from the plant locations to the warehouse location, and from the warehouse to the demand location. So the first set of transshipment constraints are transshipment constraints for this part of the supply chain. So if you look at this carefully, if you consider this part of the supply chain, everything coming into the plants from all the suppliers has to go out to one or the other of the warehouses. So you have transshipment through the plants. That's the first set of transshipment constraints. The second set of transshipment constraints are everything coming from plants into the warehouses has to be shipped to one of the market locations. Nothing can end up at the warehouse location or at the plant location. We're essentially assuming that there is only transitional inventory at both plants and warehouses. Now, this might not be true in real life. There is a potential that maybe you have warehouse sales, and so you can have direct sales to customers from the warehouses, in which case the constraints will look slightly different. But we're assuming that here all demand is happening at the markets directly. So warehouses and plants are all transitional locations. So that's the second transshipment constraint. That's what you have here. And of course, this is the capacity constraint at the warehouse, saying that the number of units that are shipped out of the warehouse cannot be more than the capacity that's available at the warehouse. And finally, demand has to be satisfied at the demand locations, and that's what you have here. So here you'll notice that whenever you have a subscript H, that is for your supplier. Whenever you have a subscript I, that is for the plant location. Whenever you have a subscript E, that is for the warehouse location, and whenever you have a subscript J, that's for the demand location. So I is for I is for the plant location, J is for the demand location, H is for the supplier, and E is for the warehouse. That's how these are set up. And so in case you're looking to see, well, what exactly does this represent? Well, this is transshipment through the warehouse, because E is the warehouse. And this is for all potential E's. This is transshipment through the plant locations, because this has a subscript of I, right? Okay. With this, let's look at a example. I'll set this up in Excel. We'll solve it, and that's what we're going to do, right? So this is just a supersized version of the problem that we were looking at in that I had in the last video, right? So here I have some data. You'll notice that I have some data, and you'll notice that these are, so let's go through the data here. We have 3 suppliers in China, India, and the Philippines. They supply to plant locations, potential plant locations that we have in China, Japan, India, and Mexico. So these are the 4 potential plant locations we are considering, and these are the transportation costs, variable transportation costs going from your supplier locations to the plant location. So if you transport 1 unit from 1 million units from a supplier in China to your plant location in China, it's going to cost you $1.90. But if you do it from supplier in China to plant in Mexico, it's also going to cost you $1.90, right? And these are all the variable cost values that are given to you, right? So with that, we have the first set of, this is the first part of the supply chain, going from your supplier to your plant locations. Now, from your plant locations to your demand locations, plant locations to your warehouse locations, these are the costs of production and transport, variable costs of production and transport. You also have capacities for your supplier. Your China supplier has a capacity of 350, India supplier has capacity of 290, and the Philippine supplier has capacity of 310. This is all in millions of units, right? And these are the variable costs that you have for production and transport from your plant locations to your warehouse locations. Couple of things to remember here. We don't know which of these plant locations are going to open, and we don't know which of these the warehouse locations are going to open, right? So we have to keep that in mind. Now, once you open the particular plants, these are the costs of running those plants. So this is the variable fixed cost of running the plants. And of course, you have capacities for each of the factories, and they're all here. That's good. So you'll notice that the number of units that our total plants can produce is 1,330. This is all in millions of units, but let's, for the time being, say 1,330. You'll notice that the supplier capacity is 950. So that's the maximum we can get from our suppliers. But if you look at demand, if you add up total demand, that's only 850. So because demand is 850, our suppliers will be able to supply all the supply that we want, and we have enough factory capacity. In fact, we have a lot of factory capacity. We have enough factory capacity to manufacture all the 850 million units that we have demand for. And of course, even the warehouse, if we add up the warehouse capacity, that's 1750. That's way more than we need. So we are obviously not going to open up all the plant locations, factory locations, and we are obviously not going to open up all our warehouse locations. We just need to figure out which we need to open, right? So the way to think about this is, when you have multiple stages in the supply chain like this, every time you add a stage, you're adding a set of decision variables and you're adding a couple of constraints, right? So let's set this up. Let's see what this looks like, right? So as usual, whenever you have a problem like this, we have to set up different sets of decision variables for each of the groups that we are considering. So I'm gonna copy this over. Let's do it group by group. So for the first group, we have our decision variables here. I'm just gonna paste it over there, right? So this is the decision variables for the first group. These are the decision variables for the second group. I am including fixed costs because obviously we need the 1, 0 variables. So this is open, close. Whether or not we're opening these particular plant locations. Again, I'm going to do that. And finally, the same goes for the warehouses. Are we or are we not opening these warehouses? So this is also going to be an open close variable, right? There you go. So okay, good. So here we have, just gonna color my decision variables like I usually do. Oh. These are all my variable cost values. variable cost decision variables. There you go. And of course my fixed cost, these are my y variables, the 1, 0 variables. Okay. Those are my 1, 0 variables. So we have decision variables, the 3 sets of x variables and 2 sets of y variables. Now next, the next step is to write the objective. So let's write that. The objective function. So the objective function has to take into account cost. So that we have 2 fixed costs, 2 sets of fixed costs, and 3 sets of variable costs. But the way we have written it, we can sort of include the fixed and the variable costs for the plants and the fixed and the variable costs for the warehouses together. So we can write a single sum product function for the whole thing. But still, we'll have to write 3 separate sum product functions. So let's write the first sum product function, which is the corresponding variable cost of shipping materials from your suppliers to your plant locations and the corresponding x variables. That's the first sum product function, the first part of the supply chain. For the second part of the supply chain, we have the fixed cost and the variable cost together, comma, the x and the y variables together, right? So if the particular plants are open, the fixed costs are assessed, otherwise they are not assessed. So that's something to keep in mind. Plus finally the sum product function, again for the third part of the supply chain, where we are including the variable cost and the fixed costs, right there, comma, the corresponding x and the y variables, right there. There you go. So 3 parts of the supply chain and 3 sets of costs. We're adding them all up, including fixed and variable costs. And that's my objective function, right? There you go. Now, once you've done that, now we have to write constraints. And we have to write many constraints, as you remember. So go back, you'll notice we have one supply constraint. So one supply constraint, one capacity constraint for the plant, one capacity constraint for the warehouse, one demand constraint. And we have 2 sets of transshipment constraints. So in total, we have 6 different sets of constraints, and we have to write all of them. So let's get to it. So let's begin with the supply constraint, right? So I'm going to write supply constraints first, and supply constraints for are for my suppliers. So let me copy that over. Supply constraints. There you go, supply constraints. And this is the amount supplied and of course the supply available. Right, so I'm just gonna box them. I like boxing. So the amount supplied, the total amount supplied from the Chinese supplier, that's your Chinese supplier and that's your Chinese plant location. So if this is confusing, having China here and China here at the same time, you can say China-supplier and you can say China-plant location just to differentiate them. But this is the total units that are supplied by your Chinese supplier to the Chinese plant location, the Japanese, Indian, and Mexico plant locations. That's the total amount supplied. And the supply that's available, we know that the supply that's available is the supplier capacity. There you go. Once we have that, I'm just going to copy my constraints over. So this was a simple example where you could copy the constraints over. Okay. The next step is after the supply constraint. So we'll go from the left to the right of the supply chain. So we wrote our supply constraints. The next step is to write the transshipment constraints from the supply location to plant location. And you know what? Let's write the plant. Next we'll write plant capacity constraints. Before we write the transshipment, let's write the capacity constraint for the plant. Plant capacity constraints. So these are the constraints that tell you about plant capacity. So we have 4 plants. Put that down here. So these are capacity constraints for the plant. If you look here, you will notice, these are the capacity constraints for the plant. We are saying that any items that are shipped from the plants to the warehouses cannot exceed the number of units, the capacity of the plant that you have. Now, we have the transshipment constraints here first, and then the plant capacity constraints. But in my mind, you have, say for example, we wrote the supplier constraint before we write transshipment from supplier plant to warehouse. It makes sense for me to write the plant capacity constraint, but the order really doesn't matter. This is just something I'm thinking about in my mind. So let's write the plant capacity constraints first. So this is the amount supplied, amount, the number manufactured. I can say amount manufactured. And it really, frankly, doesn't matter. Well, let's say amount manufactured and amount supplied. Capacity. So the amount manufactured is the total amount manufactured in the plant. So everything that's manufactured in the Chinese plant and shipped to the Chicago, New York, LA, Knoxville, and Atlanta warehouses. Now again, we're going to add them all up, but remember, we might not be opening them all. But again, we will restrict those X's when we come to writing the capacity constraints for the warehouses separately. Right now, we are saying that all potential items that are shipped out of the Chinese plant to all your potential warehouse locations, that cannot exceed the capacity of the plant. And the capacity of the plant is, well, if the Chinese plant is open, the capacity is 350. If it is not open, then the capacity is 0. So you're going to say 350 times whether or not the plant is open. So if the plant is open, then it will be 350. If the plant is closed, then it will be 0, right? Okay, so K times Y. So that's our capacity constraint. So again, I'm just going to copy this formula down. This is the amount manufactured at the plant, and this is the capacity of the plant, right? Now, once we have the plant capacity constraints, now let's write the transshipment constraints going from supplier to plant and then to warehouse. So I'm going to write supplier, plant, warehouse, transshipment. So I'm just going to call it supplier, plant, warehouse. Why not? So the transshipment is happening through the plants. So I'm going to do that. And so this is the amount. This is the coming in and going out. So if you look at the picture, we are saying the number of units coming into, say, the Chinese plant from all the suppliers has to be sent to one of the warehouses. So total amount supplied has to be shipped out to one of the warehouses. So let's do that. So number of units coming in. All the units coming into the Chinese plant is all the units coming in to the Chinese plant from the 3 supplier locations should be equal to the number of units going out of the Chinese plant, number of units going out of the Chinese plant, right? So these are all the units going out of the Chinese plant, and this is the number of units coming in to the number of units coming into the Chinese plant, number of units going out of the Chinese plant, right? There you go. So that's the first constraint. Now, whenever we write transshipment constraints, we're going to have to write both sides for all of them. We cannot just copy the formulas down. That's just the way it works, because some of them are rows and some of them are columns. So, right. Let's write this again. So sum of everything coming in to the Japanese plant should be equal to the sum of everything going out oops, sum of everything going out of the Japanese plant, everything going out of the Japanese plant to the different warehouse locations. Next, sum of everything coming in to the Indian plant should be equal to the sum of everything going out of the Indian plant. Again, remember, don't choose the open close variables. They are 0 ones. They will throw your numbers out. Finally, Mexico, sum of everything coming into the Mexican plant from your suppliers, all the supply coming into the Mexican plant and all the supply going out of the Mexican plant, right? Right, so that's the transshipment constraint. So we have the supplier constraint, supplier capacity or the supply constraint. We have the plant capacity constraint. Then we have a transshipment constraint. Now let's write the warehouse capacity constraint, and then we can write the plant to warehouse to market so transshipment constraint, and finally we'll write the demand constraints for the market. So let's write the warehouse constraint next. Warehouse capacity constraint. So we're writing the warehouse capacity constraint, and then we'll write the transshipment constraint, and finally the demand constraint, right? The supply constraint, capacity, yeah, that's it. Let's write the warehouse capacity constraint. This is the amount stored at the warehouse. And this cannot exceed the capacity of the warehouse. So these are all my warehouses right here. Put them down here. Right here. So the amount stored at the Chicago warehouse, this is the total amount that is stored at the Chicago warehouse. You can say everything that's going out of the Chicago warehouse to all the different demand locations. So that's the amount stored at the Chicago warehouse. Now, another way of looking at it is the sum of everything coming into the Chicago warehouse from all the plant locations. But we are going to write a constraint saying that they have to be equal to each other. That's the transshipment constraint. So sum of everything going out of the Chicago warehouse, that's the total capacity, cannot exceed the capacity of the Chicago warehouse. The capacity of the Chicago warehouse is either 350 or 0, depending upon whether or not the Chicago warehouse is open. So 350 times the corresponding Y variable. So this is just like we're writing another step in the transshipment constraint. So the reason why I chose to use this rather than the column for the Chicago warehouse is because this way I can write one set of constraints and just copy my formulas down, make my life easier, right? So that's the warehouse capacity constraint. And now let's write the transshipment constraint. So we'll now have the plant, warehouse, market transshipment constraint. Right? So the transshipment is happening through the warehouses. So again, I'm going to have my warehouses here. Say coming in and going out. So these are the number of units coming into the Chicago warehouse, number of units going out of the Chicago warehouse. Again, because these are transshipment constraints, we have some columns and some rows. We cannot just write one set of formulas, we have to write all the formulas. So this is all the supply coming into the Chicago warehouse from the four plant locations. Now, some of them are open, some of them are not open. Again, all of that is taken care of by the capacity constraints. The total supply coming into the Chicago warehouse, and this is the total supply going out of the Chicago warehouse. Total supply going out of the Chicago warehouse, right there. Supply coming in, supply going out, they have to be equal to each other. Same goes for the New York City warehouse. Total supply coming into the New York warehouse is equal to the total supply going out of the New York warehouse. LA next. Supply coming in and the total supply going out. Next, Knoxville. Total supply coming in and the total supply going out. Total supply coming in to Atlanta and the total supply going out of Atlanta. Okay. There you go. So these are my transshipment constraints for plant to warehouse to market. So transshipment through the warehouse. This is different from the supplier plant warehouse transshipment constraint, where transshipment is happening through to the plant location. Now, the final set of constraints are the demand constraints. And as usual, I'm going to write demand constraints as columns because I've always written them as columns. I'm going to continue doing that. Let me just write this here. Yeah, that'll work. Right. It's the amount supplied. Of course, demand. So the amount supplied to the Northeast demand region, so total amount supplied to the Northeast demand region coming from the warehouses. So the nice thing about having multiple steps in the supply chain is that once you get to the final step, you don't have to worry about what happened before. All of that is taken care of by the other constraints. So total amount supplied to the market location, which at Northeast market location, should be equal to the demand of the Northeast market location, which is 150 million units. So again, once we have this written, I can just copy my formulas over, right? So Pacific Northwest, oops, let me see. Yep. So 150 for Mid-Atlantic, 100 for South, 100 for Midwest, 100 for Upper Midwest, then you have Southwest and the Pacific Northwest. So these are all the demand for the demands at the demand locations. And there you have the 6 sets of constraints, the 3, 4, 5 sets of decision variables, and of course the objective function. Everything is here. Let me just color the objective function also. I'm just going to color. So that's my objective function right there. All right. So with this, we have done all our setup. Let's put it into the solver and solve it, right? So solver. So I'm going to change this to simplex LP. The objective is to minimize costs. And the objective function is right there. That's my objective. The changing variable cells is where you have to be careful. You have 3 sets now. Did I change my objective? A31, no. All right. Changing variable cells right there. You have the first set. Don't forget the comma, the second set, comma, the third set, right? First set, second set, third set, once we write the constraint, the sheet will go away. You don't really need the sheet here, but it just because I have a Mac. That would just looks like that. All right. Now, let's write the constraints. I'm going to begin with the supply constraints. Now, the supply constraints are going to be less than or equal to, so the supply and the capacity constraints are going to be less than or equal to, transshipment and demand constraints are going to be equal to. The simple reason for this is if you look at this as a regular, like a distribution network problem, we have more supply than demand. So demand is the one that's constraining the system. So demand constraints are going to be equal to constraints. So total amount supplied is less than or equal to the supply that's available. So that's the first set of constraints on the amount supplied less than or equal to the supply available. It cannot be more than that. I'm going to click on add. Next, the total amount that is manufactured at each of the plants has to be less than or equal to the capacity of the plants, right? So the total amount manufactured at each of the plant has to be less than or equal to capacity of the plants. I'm going to click on add. Then, of course, then is the transshipment constraint. So total amount that is shipped into the different plant locations has to be equal to the total amounts that are shipped out of the plant location. So you ship in raw materials, and then you manufacture them, and you ship out your final products to the plant, to the warehouse location. So that's my first transshipment constraint. You'll notice that it's an equal to constraint. Next, warehouse capacity constraint. So this is the total amount that is stored at each of the warehouses cannot exceed the capacity of the warehouses. Remember that when we wrote capacity constraints, we used the y variables on the right hand side to know whether they are open or not, right? So once you have that, I'm going to click on add. Next is the transshipment constraint, the second transshipment constraint. Transshipment through the warehouses. Everything coming into the warehouses has to leave the warehouses. There you go. And finally, demand constraints. You're saying that all the amounts that are supplied to the different demand regions have to be equal to the demand at the demand regions, right? All the total demand at the demand regions. And then I'm going to press OK. So we have 3 less than or equal to constraints. So you have the supply constraints, the capacity constraint for the warehouse. Then you have the transshipment constraint from supply to the plant to, this is the capacity constraint for the plant. So you have supply constraints, capacity constraint for the plant, transshipment constraints from supplier to plant to warehouse. Then you have capacity constraint for the warehouse, transshipment constraint from plant to warehouse to demand locations, and of course demand constraints at the demand locations, right? So once you have all of this, we are still not done. What we are missing is we have to write a binary constraint, right? So you have to say that all of these variables here are binary. Now, there are 2 sets of binary constraints here. I'm going to write them separately, but technically you don't have to. You can choose this and then press comma and you can choose this, but I'm going to write them as separate constraints. And these are the second set of binary constraints saying that they all have to be binary, right? So you got 2 sets of binary constraints and all the 6 sets of constraints for all the transshipment and the capacities and whatnot. And now we are done. I'm going to click on solve. It's going to take a couple of seconds, but it is going to find a solution. And this is our final solution. Now, you'll notice that sometimes you see this number. So E minus 14 essentially means it's 10 raised to minus 14 or 0.00014 zeros, and then the number comes up. That's just Excel's way of saying that it is 0. So whenever you have such a number, I would say that you can, one way to get rid of it is, you see the, this is what the number type is. I'm just going to say it's a number with no decimal places. You'll notice that. These are all numbers with no decimal places. They're all zeros, right? So this is my final solution. So according to this solution, I am opening the Chinese plant, the Indian plant, and the Mexico plant. I'm not opening the Japanese plant. As far as warehouses are concerned, I'm opening the Chicago warehouse, the Knoxville, and the Atlanta warehouses. I'm not opening the New York or the LA warehouses, right? So because I'm not opening the New York and the LA warehouses, you'll notice that nothing is being sent there and nothing is being sent out of there, right? So our constraints worked. The same goes for the Japanese plant. Nothing is, because plant is not open, nothing is being sent there and nothing is being sent out of there, right? And that's it. So the total cost for this is, let's make this a dollar value. So $1.445 million. That's the cheapest way of running this supply chain. And this is the final solution. So we know which plants are opening, we know what's happening. Oh, let's look at the capacities, right? So if you look at we had 3 constraints here, which were less than or equal to constraints. These were all equal to constraints. So you'll notice that again. I'm just going to make those number format and get rid of that. Just really, really small numbers, right? So you'll notice that because these 3 constraints were equal to constraints, the left-hand side numbers and the right-hand side numbers are exactly equal to each other, right? Now, if you look at the less than or equal to constraints, you'll notice that the Chinese supplier had 350 million units available. You're just using 250 million units. The Indian and the Filipino supplier, you're maxing out the supply that's available at them, right? Available with them. Now, as far as the plant capacities are concerned, you're maxing out the plant capacity at the Chinese plant. But for the Indian and the Mexico plants, you're not maxing out the capacity. For the Mexican plant, you're 10 units less than capacity, and for the Indian plant, you're manufacturing close to 190 units less than the capacity of the plant. As far as the warehouse capacities are concerned, you are using up the full capacity at the Chicago and the Atlanta warehouses, and you're only using 150 million units out of the 350 million units available at the Knoxville warehouse. That's because you only need 850 units, while once you open 3 warehouses, you have a capacity for 1050 units, so 200 units extra, right? That's it. So that's the final solution. This took a while for me to go through because we were looking at all the steps and I was taking it slowly. But you will notice that all the concepts that we used here, we had used in the previous capacitated facility location model. The only thing that we did was add an extra layer. As you can see, this means that if you had more steps to your facility location model, then you can just add more steps, add more transshipment constraints, add more of these capacity constraints, and then you can formulate the problem. The difficulty is not that much more, at least that's my opinion, right? Okay, so I'm going to end the video here. It's already pretty long, but I'll hope to see you in the next video. Take care.